Welcome back everyone. Today I'll be discussing about the summation of first n squares. As you can see, we'll take 1 square plus 2 square plus 3 square all the way to k square, where k is a positive integer. So to help us with our proof, we'll be using the two bullet points which I write down in green. One of them is the k plus 1 cube, and the other one is discussed in the previous video, the summation of k. So if you would like to know about the proof, the link to this video will be in the description. For now, I'll be showing the proof and how to derive the formula for the summation of the first n squares. So to start off, we'll be using the telescopic sum, and we'll also use the k plus 1 cube formula. So for the telescopic sum, as I mentioned about the telescopic sum in the previous video, what it is basically telescopic sum is where the subsequent terms are cancelled out. So what happens is this leaves behind the first and the last term. So the first term and the last term are not cancelled out. The other terms in the equation are all cancelled out. So we'll make use of k plus 1 cube to do the telescopic sum. So k plus 1 cube minus k cube, we all know it's equals to k cube plus 3k squared plus 3k plus 1 as shown above here. And we're going to subtract by k cube. And this cancels out. So this gives us 3k squared plus 3k plus 1. Now we'll be doing the telescopic sum, the summation of this thing. K plus 1 cube minus k cube is, this is supposed to be k. Yeah, so just to make sure, yep. So when k equals to 1, we will have 1 plus 1, which is 2 cube, and minus 1 cube because k equals 1. Now we'll increment to increment, so now k equals 2. When k equals 2, k plus 1 is 3, and we have to cube it, and minus k cube, which is 2 cube. Now k equals 3, so 3 plus 1 is 4 to the power of 3 minus 3 to the power of 3. And this goes on and on until we reach k equals n minus 1 and k equals n. So when k equals n minus 1, n minus 1 plus 1 will give us n cube, and minus k right now is still n minus 1, so yep. And now k equals n. So when k equals n, k plus 1 equals to n plus 1 cube minus k, which is n cube. So we're going to do a telescopic sum. We can see that we have a 2 cube here and a negative 2 cube here, which will cancel each other. We have a 3 cube here and a negative 3 cube here, which will also cancel each other. The 4 cube will cancel out with a negative 4 cube, which is behind. And for the negative n minus 1 cube over here, it will cancel out with a positive n minus 1 cube, which is in front of it, within the dots. Yeah. So, and for n cube will cancel out with the negative n cube here, and hence this leaves us with two terms, n plus 1 cube and negative 1 cube. So this whole thing here equals to n plus 1 cube minus 1. Alright, and for this equation right here, I'm gonna expand it out. In fact, we have already expanded this equation over here already. Yep. So this whole thing can be rewritten as 3k squared plus 3k plus 1. So, and this equals to this. Now I'm going to rewrite this at left hand side of the equation as this, and the right hand side of the equation I'm going to expand it out. So the negative 1 and the 1 will cancel each other, and we'll left this as for the right hand side of the equation. Now, as I mentioned just now earlier on in the video, we will make use of this formula the second bullet point, the summation of k, which is equals to n times n plus 1 over 2. We're going to use it here. So this is equals to 3 times n times n plus 1 over 2. And for this third term here, it's going to be n. And for this, actually our main objective is to find this. We don't know the formula for the summation of k squared. This is what we're trying to find. So we're going to keep it here. Alright, so now I'm going to expand this whole thing. So this whole thing is basically 3 over 2n squared plus 3 over 2n plus n equals to n cubed plus 3n squared plus 3n. So now I'm going to subtract the left hand side and the right hand side of the equation with 3n squared plus 3 over 2n plus n. So I can get rid of this on the left hand side. So n squared plus 3n minus this whole thing. So we're going to have 3 over 2n squared minus 3 over 2n minus n. And this is equals to n cubed. This is equals to n cubed, and 3n squared minus 3 over 2n squared would give us 3 over 2n squared. Now 3 over n minus 3 over 2n minus n will give us n over 2. Now we have this 3 over here. Is what, to get rid of the 3, we have to divide the left hand side and the right hand side of the equation by 3. So for the left hand side we will get what we want, the summation of k squared, and the right hand side will divide by 3, and this will give us n cubed over 3 plus n squared over 2 plus n over 6, which is the answer, which is the formula to the summation of k squared.